Assalamualaikum, salam sejahtera to our lecturer Dr. Khairul bin Kamaruddin. Today, I and my group member will present the assignment that had been selected, which is development of smart plastic injection molding with conformal cooling channel. First of all, I would like to introduce my group member. Muhammad Muhammad bin Yahya will present about the methodology of this assignment, and then me, Nurlaili Fatih binti Jabidi, will present about the introduction of this assignment, and then Muhammad Ikwan Hamizan bin Jamaluddin will present about the conclusion of this assignment, and then Muhammad Luqmanul Hamri bin Abdul Malik will present about the finding of this assignment. Introduction. The widely used in manufacturing industry is injection molding, because injection molding can creating a complicated shape of the ideal of product for mass production and particular interested in production of plastic. Injection molding process is where to get the product form by injecting heat melt plastic materials into the mold and then cooling and then solidifying it. Injection molding have 6 major steps, which is clamping, injection, dewelling, cooling, mold opening, and the last step is removal the product. But in this assignment, we only focus on the cooling stage, because where the evolution of a smart plastic injection mold with conformal cooling channel to creating a complex automotive component with variable thickness at certain position, because compared to the traditional cooling channel, it will reduce cycle time about 30%. This is important because in this study, develop a conformal cooling channel can apply in a injection molding of medium size, which make a part of an automotive. In fact, the existing mold may be modified to reduce cycle time and increase the quality of the molded component. In injection molding, cooling stage is a very important because it amount for more than 2/3 of the molding cycle. Using 3D printed mold made of spiral cooling channel, making a large mold by 3D printed molding is very expensive. There are 2 objectives that we want to achieve. First is to know the detail about the development of a smart plastic injection molding with a conformal cooling channel. And the second is to explain in the video about the development of a smart plastic injection molding with conformal cooling channel. And then the scope is only a selected paper, which is development of a smart plastic injection molding with conformal cooling channel.
Assalamualaikum and good morning. My name is Muhammad Muhammad bin Yahya. I will explain about the methodology. The methodology can be divided into 2 parts, which is the mathematical analysis and physical modeling of cooling process. In terms of physicality, a heat transfer problem in a cooling process of injection molding is so complex and very specific. An analysis can be made at the molded part and the mold region to find the cycle average temperature and the transition that approach. And a partial differential equation can be made during the governing transition of heat transfer problem that also involve the general heat conduction. Now, lastly, a steady state Laplace heat conduction equation can be formed when a cycle average temperature distribution is represented. There are a few formulas that we can use in finding a heat transfer in the mathematical analysis for cooling process. First is the heat balance, which the equation is Q dot M plus Q dot C plus Q dot E equal to 0, which Q dot M is the heat flux from the mat. Q dot C is the heat flux exchange with coolant, and Q dot E is the heat flux exchange with the environment. The second formula is the energy balance simplified by neglecting the heat loss, which is Q dot M plus Q dot C, not include Q dot E. Then is the heat flux from the molten plastic into the coolant, which the formula is Q dot M equal to 10 the power of negative 3 times Cp times Tm minus by Te, and then plus Im, and then multiplied by the P S over 2x multiplied by x. Okay, the Cp is the specific heat of plastic, Tm is the melt temperature, Te is the latent heat, Im is the specific weight, P is the molded part thickness, and S is the pitch between the cooling lines. And then we go to the heat flux from the mold exchange with coolant in the Tc amounts. This is the exchange of the surrounding temperature and the coolant temperature which the part is. So the formula is the Q dot C equal to 10 the power of negative 3 multiplied by Tc, and then multiplied by 1 over 10 to the power of negative 3, and then the A pi D times by 1 over K multiplied by USE in bracket. The whole thing is in the power negative 1, and then times by Tw minus Tc. So the meaning is that Kp is the thermal conductivity of polymer, D is the cooling diameter, Kst is the thermal conductivity of mold steel, Se is the shape factor, Tw is the mold wall temperature, Tc is the coolant temperature. Part of methodology is the design and simulation of conformal cooling channels. Due to high demand of production and a short amount of time for producing a product lead to the significance of benefit, a good and well designed of cooling system can increase the quality of mold part. As we can see, the figure 1 below shows the cooling system of today's mold design and the temperature distribution of the mold part. Okay, refer to figure 1b. There are two regions with high temperature. This is because the mold part is large in thickness, so the part absorb more heat. So the hotter the part at the regions, it need to be done by local treatment. The treatment is using the conformal cooling channel. We use a simulation tool software of mold flow to develop the new cooling system, as well as to analyze the thermal performance of original mold. It means that the old mold can be reused by deploying the old mold with the new cooling channels. This is one of the ways to solve the design of a hot regions by using a simulation software, so we can analyze there. There are 4 types of conformal cooling channels, which is the zigzag type, which it helps to slow down the weaken the flow rate of coolant. It also can have many unnecessary turnings, which is the properties of the types, zigzag type. And then is the scattered type, which increase the pressure drop in coolant flow in a cooling circuit distance. It also not sustain a turbulent flow due to pressure drop. The third one is the spiral type, which is very common we use in this project. It gives low cooling pressure drop. It also control the heat removal locally by control the position of cooling channels. And then lastly is the Vogel diagram type, which gives better cooling lines around mold surface and high pressure drop and uneven velocity of coolant. Thank you. That's all for me.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Munahambri Bakamali, and today I would like to presenting about our finding in the report assignment. So, for the result, especially you can see there are different picture, the part temperature distribution. So, A is conventional and B is a conformal cooling channel. So the figures show the simulation result of the conformal cooling channel that giving a better temperature distribution than the original cooling channel, which breathless system. So we can see that the average temperature of the conformal cooling channel of the part is lower than the conventional cooling channel. So you can see there are different, the dark blue and B and A is not difficult or not the thickness of the dark blue is lower than the B. So the cooling time is short. So we can see the variation of part temperature of the conformal cooling channel is smaller than the original cooling channel. So the lower temperature variation of the mold part will produce residual stress warpage of the mold part. In every part, you can see in every part they are have a different color and different version of the part of the picture. So in conclusion, the conformal cooling channel is better than the conventional one. So I would like to presenting the alright, so I would like to continue presenting about the temperature distribution of the cooling channel. So you can see there are different figures shown in below. So the mold have the ability self adjustment of the mold temperature to make them to work smart. For you can see the flow rate of the coolant can be controlled in inlet temperature because this method is faster and more cheaper than others. So you can see all the pictures below show a level of the mold temperature can that distribution of the coolant flow rate. You can see at the picture 1 is 5,000. Second picture is 10,000. 100,000, and third one is 150,000, and the last one is 200,000. So in this case, you can see there are different shapes of the temperature that exactly different by the variation of the part of the picture. Right, so this is all for me. Thank you very much.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ikwan Hamizan bin Jamaluddin, and today I would like to present about the conclusion. In conclusion, what we can see is that all of our objective is achieved. We are able to explain more in the video about development of smart plastic injection molding with conformal cooling channel. Other than that, we also understand the cooling process is very critical as it accounts for over 2/3 of the molding. Furthermore, for the third point, which is since it introduced a conformal cooling channels applied in a medium-sized injection mold, that makes an automotive part, the existing mold, managed to be improved in order to reduce the cycle time and improve the quality molded part. So as a result, what we can see is that adding conformal cooling channels which are used to cool extremely hot location in the mold is a very smart solution. In addition, the construction of a conformal cooling channel was achieved using the method of the integrating analytic and CAE simulation. Okay, for the last one is overall the spiral cooling channel was selected as the best alternative. That's all for me. Thank you.